Hello guys, this is my Physics 2211 Lab 5, and this lab was choosing your own lab to do. So the agenda for today, I will go into the introduction of the lab that I did for this lab. I will talk about the models of this lab, talk about the experiment of what I did, then talk about the code, then end with some discussion questions and a conclusion. So for the introduction. So for this lab, I observed an object falling and I compared it to a computational model. And I compared the computational models accounting for and not accounting for air resistance or a drag force. So the fundamental physics principles for this lab were Newton's second law, force net is equal to change in momentum over change in time. The gravitational force, of course, force due to gravity is equal to negative mg and then direction, and then the drag force, which the equation is right there. And now for the models. So I had to find the starting velocity. So I used this equation, and then the position update formula I plugged into my code, and then the bottom equation shows constant velocity in the x direction and non-constant in the y because of time. So now for the experiment. So I recorded a video of an object that was falling in some way. For this lab, I just dropped it. I uploaded the video to Tracker, and then I used Tracker to obtain values, and I plugged those into the code. And then compared results from the real experiment and the theoretical computational data. So for the lab, I used a pencil case and I set that as my system. The surroundings, of course, are the earth and air, which are not important for the computational model, but are important for the real values in real life. The initial position I set as 0, 0, 0, and the velocity I set as 2, 0, 0, and I got that from Tracker. And then I weighed the pencil case, and it weighed 0.313 kilograms. So here's the experiment and the video that I uploaded to Tracker. And now for the code. So as you can see, I set b equal to 0. And then on the right, you can see that the position with respect to time is not linear, but the velocity is linear, which is important because that's not the case all the time. In the computational model, when there was drag, obviously the position changes with respect to time, but the velocity is actually nonlinear. So now discussion. Here's a graph, and I graphed both x and y velocities, both experimental and computational. As you can see, the computational models are a lot more specific, and the experimental y velocity, purple, you can see it is straighter and it doesn't curve as much as the other one. So areas for error or things to consider. Tracker when putting data points in, not always perfect when selecting my data points. Also human error, those are kind of tied together. And then improper calculations from those points that will change other factors. So now the conclusion. So what does all of this mean? So when the graph flattens out, when velocity is nonlinear with respect to time, that is terminal velocity. And that's a steady velocity an object reaches in free fall when the force of gravity equals the drag force. The model accounting for drag predicts terminal velocity as time continues. So what if the terminal velocity is the same no matter whether the object was thrown or released from rest? Only weight and drag play a role. Thank you.